All right, so we're going to work on the solving equations homework. Watch the instructional video before you watch this one. All right, and I may solve these a different way they did in the instructional video, but here is how that I do it. Find a common denominator first. We're ultimately solving these problems, but we have two fractions on the right we need to add together first, and they don't have a common denominator. So the common denominator should be 6n. It's basically everything at the bottom that you see. Don't repeat yourself. You don't need to write n or 6 multiple times. The good news with 6n is two of these fractions already have the common denominator. It's just that middle fraction that needs a 6 multiplier. Whatever you do to the bottom, you do to the top. So I'm going to rewrite this problem. And since we're solving this problem and we're not really simplifying it, the denominators, since they're all the same, aren't going to affect anything. So what we can actually do is we can mark out the entire bottom half of this problem. And now it becomes just a pretty simple Algebra 1 solve for x type problem. So we're focused on just what's at the top. So I'm going to simplify the right-hand side just a little bit. The 6 and the 1, those are like terms. So I get 4n plus 7 equals 5n minus 5. So once you get a common denominator, you can mark out the denominator. So I'm going to subtract 4n from both sides. I'm going to add 5 to both sides. So we're left with 1n, those cancel, equals 12. Remember, you always want to check your answers. You want to take 12 and substitute it back in for n in the original problem and see if it pans out. So here's the check work. As you can see, you end up with 55 over 72 equals 55 over 72. So 12 is not an extraneous solution, or excluded value is sometimes what they call it as well. All right, moving on to question 3. Same deal. Get a common denominator. Get our CD. Our CD in this problem, you could say is 8x. Some people do the 4 times the 2 and get 8x, but I'm just going to say 4x. I can use 4x because 2 goes into 4. 8x would work as well, but it would just require a whole lot more work. So I'm going to multiply bottom and top by 2x. So I end up with 3 equals, you need to distribute the 2 at the top, 2x minus 10 plus 1. And since all of the denominators are now 4x, I can mark out all the denominators. And now it is a super simple equation. Don't forget to check your answer. So you can see here pretty quickly, checking your answer. This is going to work out. I might use a calculator to make this go a little bit quicker. Get a common denominator. And that does check out. So 6 is a solution. All right, number 5. A little bit to factor here. You have perfect squares. So x squared minus 16 factors to x plus 4, x minus 4. Which means our CD is everything at the bottom without repeating ourselves. So it's x minus 4 times x plus 4. All this denominator over here needs is an x plus 4. Whatever you do to the bottom, got to do to the top. So the top, we've got 16 equals 2x plus 8. The bottoms are the same, so they cancel out. And we get 4 as an answer. When we check this answer, though, we see it pretty quickly. When we take 4 and we plug it in for x, we talked about this in section 1, 4 is actually a restriction for this problem, because we end up with 16 over 0 equals 2 over 0, and you cannot divide by 0. So 4 is actually a restriction, which means if it's a restriction, it can't be a solution. So this one is no solution. So 0 with a slash through it means no solution, or sometimes you'll see an empty curly brace, meaning the empty set. But no answer to this problem. And finally, number 7. Oh boy, fun problem here. Number 7. This one looks uglier than it is, though. So I'm going to rewrite it. I'm guessing, or at least hoping, that r plus 6 is one of the factors at the bottom of these two fractions. You need to factor the bottom. So it's going to be 2r, and that's going to be r. I think the 6 goes there, and the 3 goes there. And I think that's positive, and I think that's negative. I believe that's right. Oh yeah, that makes sense, because r plus 6 is indeed one of our factors, which means our CD in this problem is 2r minus 3 and r plus 6. So these two are already set up because they are the common denominator. This one needs a 2r minus 3, bottom and top. But then we can mark out the bottom and ignore the bottom. So we get 2r minus 3 equals r plus 5. We need to distribute this negative 1 with that subtraction symbol to all three terms. Combine your like terms. I got an r here, I got a 9r there, I got a positive 5 here, and a negative 20 here. That's negative r squared plus 10r minus 15. I'm going to get this equal to 0 since it's a quadratic. It's really the only way we can solve it. So subtract 2r and add 3 to both sides. And then basically you just need to factor that. I'm going to pull out a negative 1 to make it a little bit easier. You could do quadratic formula, I guess, at this point, if you prefer that. So our potential solutions are 2 and positive 6. A lot of times when you have 2 solutions, one of them ends up being a restriction. So if you go back to the original problem, look at your bottom factors, one of them has an r plus 6, which means r cannot equal negative 6. So we're okay. So those are both solutions.